In our last video, we talked about why we, and many other RVers, sometimes stay in cold climates in the winter. We mentioned that we'd be staying on a 30-amp campsite this year, but we're modifying our RV to take advantage of the site's additional 20-amp outlet, which is something that's pretty common. Today we'll be doing the step-by-step DIY tutorial of exactly how we're installing a dedicated 20-amp outlet for powering our new convection heater. That will meet most of our heating needs without using any of the power from our primary 30-amp connection. If you're worried about working with electricity, this job doesn't even require turning off the power, since nothing we'll be working on is connected to a live power source. Our shore power cord comes into the RV here, so it's the perfect place to route an additional cable. Making things particularly easy for us is the fact that the top of our electrical compartment is directly below our refrigerator, and under the fridge there's an easily accessible space where our furnace is located, along with the water filter for our ice maker. There's also plenty of room for our new outlet, which will mount right here on this wall. The other side of the wall is where we'll put our heater, making it the perfect place for our dedicated 20-amp outlet. We'll be using the following tools: a hammer, flat blade and Phillips head screwdrivers, a heavy-duty wire cutter, needle nose pliers, a circuit tester, a utility knife, a cordless drill with a long 1/2-inch bit, wire strippers, safety glasses, and a Dremel tool with assorted cutting bits. Our LED work light will come in handy too. We'll also need an electrical box, a 20-amp outlet and a cover plate, an outside electrical box and a 20-amp inlet, a strain relief and glue, some Romex cable and hammer staples, and a heavy-duty 20-amp extension cord. 15-amp outlets have two vertical slots that accept the vertical blades of typical household plugs, but 20-amp outlets can accept a vertical or horizontal blade in one of the slots. Since we're using this outlet to power a heater, we're going to overbuild it with 20-amp connections throughout. That includes a 20-amp inlet in the electrical compartment and a 20-amp extension cord. Even though we would have been fine with 15-amp connections, we're taking the extra safety step of making sure that we can only use our new mod on more robust 20-amp circuits. We're also using heavy-gauge 10-2 Romex, which again can handle more amperage than we'll be putting through it, just to be extra safe. This is where our long 1/2-inch bit comes in, to drill a hole for the Romex to pass through. After some extremely careful measuring to be sure we're in the right spot, we drill the hole for the cable. We hold our breath, and then, right on cue, our bit comes through exactly where we wanted it. We're going to mount our electrical box right against this stud to make it as solid as possible. If we cut our hole correctly, the box will go right here. We drill a small pilot hole next to the stud. This marks its location for us on the other side of the wall. Now we'll line up one side of our box with the hole, and holding it square to the floor, we trace along all four sides with a pencil. Complete the outline of the box with a straight edge. We use our Dremel tool to start cutting through the wallboard. Obviously, interior RV walls are much thinner than the gypsum wallboard in a sticks and bricks house. We finish cutting through the wall with a straight bit. You don't need to worry about making the cuts perfect because the wall plate will cover them up. Now our box should fit right into the opening. You can see we've placed it right against the stud so the outlet will be held in place as solidly as possible in the thin, flexible wallboard. Now let's feed our Romex up from the electrical compartment. Then we'll bend it through the opening in the wall so that it sticks through about 6 inches on the other side. We'll secure it in place with a hammer staple. In preparation for installing the box, we'll pop open one of the knockouts. We've made a mark where the Romex will pass into the box, and we want to strip the outer casing to within about an inch of that mark. If you're using a utility knife, like we are, be sure to score the outer casing right down the middle. That's because the bare ground wire is in the middle, and if you run your razor knife down either side, you could nick the insulation on the inner black or white wire, which is important to avoid. Professionals often use a special tool for this, but if you gently score the Romex right down the middle, you should be fine using a utility knife. Peel back and cut away the outer casing and paper, and carefully inspect the insulated wires to confirm you haven't nicked them with the blade. Now insert the cable into the opening in the box, and insert the box into the wall. Make sure that you have about an inch of the orange Romex casing sticking into the box. Using a Phillips head screwdriver, secure the box into the opening. The first quarter turn flips the tabs up. Then just tighten them down securely to hold the box in place. They adjust to wall thickness automatically. There are 3 connections to make on the outlet: a green screw for the ground wire, silver screws for white, and gold screws for black. The strip gauge on the back of the outlet tells us how much insulation to remove, in this case about 3/4 of an inch. So we strip that much off the black and white wires. Now we'll use our needle nose pliers to make a hook in the end of each wire to go around the screws. Even if your outlet has holes to insert the wires straight into, don't use them. Those are great for fast assembly, but not for solid, long-lasting connections. Connect the ground wire first, placing the hook around the screw, with the end of the wire on the side you'll be tightening toward. Remember, righty-tighty. Then use the needle nose to crimp the wire into a tight circle. And tighten the screw firmly, since it's important for the connections to be solid. Now do the same thing with the white wire, crimping it into a tight circle around one of the silver screws. Then tighten it down firmly. Be sure to screw in and tighten the unused screw. We won't be needing it here since this is a single outlet with no other connections needed. Lastly, crimp the end of the black wire onto the gold screw directly opposite the white wire. Tighten it down firmly, and tighten in the unused screw. Carefully bend and flex the wiring, pressing the outlet into the box, and tighten the 2 screws that hold the outlet in place. Now we can install the faceplate, and we're all done with this outlet. For the inlet, which goes down in the electrical compartment, we've chosen this heavy-duty outdoor box. We're just going to install a strain relief to add protection for the Romex cable. We wipe a little PVC cement onto the strain relief. Insert it into the hole and give it a half twist. Then set it aside to cure. In the electrical compartment, we've routed our cable down the wall to where the box will be mounted here alongside our transfer switch. We used a hammer staple to secure the cable into the wall and added a piece of split loom on the upper section so that it blends in more with the other wiring up there. Again, we've marked where our Romex will come into the box. We'll want about 6 inches of wiring available, so we'll cut off the excess. Using the same technique as before, score the Romex casing right down the middle with a utility knife. Then cut away the casing and the paper, leaving about 6 inches of wiring exposed. Push the wires into the box, making sure there's about an inch of the orange Romex casing visible inside. Now we can secure our box to the wall. This was a convenient place to mount it since the wall is plywood. Then we strip the casing off the ends of the white and black wires. Now we're going to connect our inlet. That's right, this is an inlet, not an outlet. The only way to attach this type of inlet is using the straight-in wire connections, so we'll push each wire into the appropriate opening. First, tightening the ground onto the green screw. Then the white wire onto the silver screw. And finally, the black wire onto the gold screw. Then bend the wiring as needed and push the inlet into the box. Now install and tighten the 4 screws that hold the inlet in place. We've also secured the Romex with a hammer staple right outside the box. Since this box is designed for outdoor use, it came with a gasket, but since we've installed it into a weather-tight indoor space, it's not required here. The installation is complete, so we're ready to plug in our 20 amp extension cord and power up our new outlet. Then we'll plug into the 20 amp outlet on the park pedestal. Again, keep in mind that we've overbuilt this to work on 20 amp circuits only. Now let's turn on the breaker, and we see that our extension cord lights up when the power's on. We then use our circuit tester to make sure we've wired everything correctly. 2 yellow lights means all's well. We'll also add a little bit of silicone around the hole we drilled up through the floor, just to seal things up. To meet most building codes, Romex isn't supposed to be left exposed, but we're leaving this small amount visible in this protected area where it's extremely unlikely to be harmed by anything. Now we have 2 cables coming out of our electrical compartment, following the same path over to the power pedestal. Our primary heater now draws strictly from a power source completely separate from the rest of the RV. That leaves all of our rig's 30 amp main power supply for the additional heater and everything else we need to live. And because we're paying for metered electric here, we're not taking advantage of anyone by using both available power outlets on the site. We've already had sub-freezing temperatures, and we've been cozy and warm without using a drop of propane to enjoy a comfortable winter stay. Hopefully this project gives you some ideas how you might modify your own RV in a similar way. If you like our videos, don't forget to subscribe and comment, and give us a thumbs up. Safe travels, and thanks for watching.